Hey guys, great to be back with you all again today. We're going to be talking about problem solving today. And we're going to be talking about a wide variety of skills, really. We're going to be talking about 3.4 A and K and 3.5 A and B. And that's problem solving with all operations, basically what it is. And the I can statements is I can choose the correct operation to solve a word problem, and I can use the correct strategies to solve to problem solve. So we're going to look at some of the vocabulary. Since we're using all operations, that would be addition, subtraction, multiplication, and division. Those are the four operations we use in math. And we have for addition, we have add in, are the two numbers we put together to get our sum, which is our answer. And minuend and subtrahend and difference. Difference is the answer to a subtraction problem. There's a community property of addition. That means I can switch the numbers around and still get the same sum. That's not a fact with subtraction, though. There's specific order. We always start with a larger number in third grade and take away a smaller number from that to get a whole number or a positive number. Multiplication vocabulary. It's factor, those two numbers we put together in our multiplication to get our product. And there's a community property of multiplication, which means we can switch numbers around. 5 times 4 is also 20. And division vocabulary, dividend, divisor, quotient. Quotient's the answer to a division problem. And we cannot switch around. I cannot say that 5 divided by 40 equals 8. That would not be a true statement. So there's a specific order way we divide things, just like subtraction. They're very similar. Have a few videos we're going to watch about these skills. We'll watch one of Aaron's videos talking about how to solve problems using different operations and stuff. So let's go ahead and get ready for those videos.
1. Looking for clues and keywords. In this video, you'll learn tricks for finding evidence or clues to help you solve word problems. When you're given a word problem to solve, it can sometimes be confusing. How will you know what to do to find the answer? You know that you'll need to do some math calculation, but how do you know which one is correct? This is a common problem, but don't be afraid of word problems. I'm going to show you some tricks because every word problem gives us hints, no matter what the problem is. It's true. What are some common clues? Let's look at them. Sometimes a word problem will ask you to add without using the word add. How will you know? There will be clues in the word problem that tell you you need to add. Those words are some, more, in all, altogether, plus, combined, total, more than, increased. These words all mean the same as add, and they are clues that you will need to add to solve the problem. Let's look at an example where the word problem asks you to add without using the word add. Okay, here's a word problem. There are 7 pencils on the desk. John drops off 2 more pencils. How many pencils are there in all? Now, how will we solve this problem? Let's look for clues or keywords. We know that there are pencils on a desk and that John comes along and drops off more pencils. The question asks, how many pencils are there in all? Do you see the clue in the question? Yes, you are right. In all is a clue. You remembered from the word list given before that in all is a clue to use addition in this problem. How many pencils in all? Or how many pencils in total? Or how many pencils all together? All of these mean the same thing, and they all ask us to add. So, 7 pencils plus 2 more pencils that John dropped off equals 9 pencils. We've solved this problem by adding. The answer is 9 pencils in all, or 9 pencils in total, or 9 pencils all together. Sometimes a word problem will ask you to subtract or minus without using the word subtract or minus. How will you know? Just like with addition, there will be clues in the word problem telling you that you need to subtract or minus. Those words are take away, fewer than, less than, difference, less, shared, gave away, decrease, change, left. These words all mean the same as subtract or minus, and they are clues that you will need to subtract in order to solve the problem. Let's look at an example where the word problem asks you to subtract without using those words at all. Here's a word problem. There are 9 pencils on the desk. Allison comes along and takes 5 pencils. How many pencils are left? How will we solve this problem? Let's look for clues or key words. We know that there are 9 pencils on a desk. We also know that Allison needed 5 of them, so she took them. The question asks, how many pencils are left? What is the clue in this question? Yes, you are right again. Left is a clue. You remembered from the word list given before that left is a clue to use subtraction in this problem. How many pencils are left over? This tells us we need to subtract. 9 pencils minus 5 pencils that Allison took equals 4 pencils. We've solved the problem by using the clues. The answer is 4 pencils left. So far, you've just learned word clues for 2 operations present in word problems, addition and subtraction. In part B of this video series, we're going to go over additional keywords for other operations. Don't forget to practice your new skills with our fun games and quizzes online, and remember to always be clever.
Hello, and welcome to 5-Minute Math. Today we are looking at the 3rd grade concept of representing multiplication and division. This is the standard 3.5B in the great state of Texas, and we're looking at number 14 of the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, and then unpause it and we will look at our answers together. So we have an interesting problem here because if you look at our answer selections, F, G, H, and J, we're not actually looking for a number. We're looking for a representation or a diagram is what they call it here. So let's see if we can figure this out. Edward made made 26 hamburgers. He used a total of 78 pickle slices on the hamburgers. Then he put the same number of pickle slices on each. So let's see if we can draw a picture of this. I'm not going to draw 26 hamburgers or 78 pickle slices, but just so we can kind of get our brains wrapped around it. So I'm just going to draw, I'm just going to do like this. What I'm going to do is I'm going to say this is 26. If I wanted to, I could draw 26 individual circles, but I'm not really going to do the problem like that. Then we've got more pickles, so I'm just going to kind of do like this. So we've got a whole lot mess of pickles. And I'll say this whole thing is 78. And what we're doing is we're putting the pickle slices onto the tomatoes or onto the hamburgers. But what we need to know is we need to have a representation in our brains of what's going on to what. So we've got the pickle slices going on to the hamburgers. Here's the key. We've got the same number of pickle slices on each hamburger. So when we're looking at same number, when we are looking at, sometimes they might use the term equal groups, or maybe they'll just say same amount. All of these are going to be your big clue that we are looking at. This down here, multiplication and division. Whenever we get into same number, equal groups, same amount, that is your clue that we are looking at multiplication and division. So when we are looking at strip diagrams, and that's what these are down here, so let me just write that. These are called strip diagrams. You might be familiar with these as part-part wholes, and a part-part whole is one kind of strip diagram. There are a few others, but as you can see, these do kind of look like part-part wholes. And in these cases, they actually put the total down on the bottom, and it's this line right here, kind of like what I drew over on the side. That's the total. Sometimes you'll see it on the top. Either way, what we have is we have a total. We only have two numbers, 78 and 26, and then how are we gonna split them up, or how are we gonna represent them? Well, your total is always going to be this big number. So let me just put that right down here. So 78, that's the total number of pickle slices we have, and we are going to divide them up. We are going to split them up, separate them up into equal groups based on hamburgers. And so what we're going to do is we're just going to put 78 on 26 hamburgers, and I'm not going to count them, but let's just pretend I put 26 little hamburgers down there. And as you can see, that's what F is right here. Now they flipped the total down to the bottom, but we have 26 little question marks. And what we're looking at is how many pickles go in each. We don't even need to know the answer to this, but this F is going to be 78 divided by 26. And that's what we're looking for. What we have here in G is we've got 26, and it's divided by 3. But we're not dividing up the hamburgers, we're dividing the pickle slices. And this equation doesn't even use the 78 pickle slices. I don't know where the 3 comes up. Here we have equals 78. So this is more of an addition. So we're trying to add 26 and 78, and that's going to get us to our total. We're not adding the pickle slices and the hamburgers. We need to divide the pickle slices into the hamburgers. So that gets us the wrong operation. And then 78 minus or equals 26 plus this mystery number. That's also an addition or subtraction problem. Not what we're looking for. We're dividing the pickles onto the hamburgers. So our answer is going to be F.
Okay, we're going to work on a guided practice problem here. Follow along as I read. Jesse has 60 party favors to give away at his birthday party. He has invited 12 friends. How many toys should he give each of his guests? So I'm going to cube this, just like I do all my problems, or most of them anyway. There's 60 party favors, and he invited 12 of his friends. And that's most of the stuff that we need to know on this. And I'm trying to find out how many toys. So I'm going to underline the question. How many toys should he give to each of his guests? I'm going to box in my operational clue. I see right here, I see each. That's usually talking about equal size groups. I'm evaluating. So I'm looking at all my labels right there. I have 60 party favors. I have 12 friends. So typically, I'm not going to add and subtract toys and friends. Okay, if I have 60 party favors and 12 friends, I can't add those together and get 72 of something. Okay, it's still going to have 60 party favors, and I'm still going to have 12 friends. Okay, so when my labels are different, a lot of times that seems like it's going to be multiplication division. I also see right there, I see the each that I boxed in. That tells me it's equal size groups. And is my answer going to be smaller or larger than 60? That's right, it's going to be smaller because there's 60 total party favors. So chances are I'm going to do some division. Okay, but before I do that, I'm going to go use my get strategy. So look at groups, each, and total. So how many groups are there in this problem? That's right. There are 12 groups because that's the friends. Those are the ones that are getting the toys. How many are in each group? That's right, we don't know. Right here in my question, I see the each, and that's what I'm trying to find out. I'm trying to figure out how many each get. So I'm trying to find that out, and that's going to be how many toys each friend gets. Do I know the total? Yep, the total is the total amount of party favors, or total amount of toys. So what expression can I use to solve this? Yep, that's going to be 60, because I know my total, I'm talking about equal size groups, divided by 12. That's going to equal something. What multiplication fact could I use to help me solve this? That's right, 12 times something, 12 groups of something equals 60. So I could use that. That's a multiplication equation I could use to solve this. Okay, so one thing we could do is we could go ahead and plug in these numbers right here to my 12 times 3. I could do 12 times 5, 12 times 6, and 12 times 12. And that'd be one way to solve it. So let's try that. What is 12 times 3? That's right. 12 times 3 is 36. So that would not be one way to solve it. What is 12 times 5? Okay. Yeah, that looks like 12 times 5 is 60. So I think that may be my answer. What is 12 times 6? Okay, 12 times 6 is 72. And what is 12 times 12? Yeah, 12 times 12 is 144. So I'm pretty sure it's B. So but we're going to do something different. We're going to do something else. We're going to use a strip diagram to help us solve this. So I'm going to draw a strip diagram right here. Kind of an ugly one, I guess. Huh? And on this, the total distance is going to be 60. I'm going to break it into 12 equal groups. I'm going to try to anyway. So 12 is an even number, so I can break that in half, and that means I'd have 6 on each side. 6 is an even number, so I can break each one of those in half. And that means I'd have to put make 3 equal sections in here to make 12. So that's 3 there, 3 there, 3 there, and 3 there. Okay. And typically, I would do this sort of similar to grouping. Let me double check, make sure I got 12 here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I did end up with 12. Okay. I'm going to go ahead and just double check using my my answer that we said. We said it's 5 in each group, and I can go ahead and draw 5 in each group. So that'd be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. And that does work. There is 5 in each group, so my correct answer on this one, it will be 5. You will give 5 party favors to each friend. It's time to complete your independent practice. There'll be a blue puzzle piece after this video. I'll also put a PDF in there that you can print out and do your work with pencil and paper. Just make sure you do the blue puzzle piece. And if you have any questions, email your teacher or send them a message in Schoology. Best of luck to you.